You don't need to keep waiting. We're gonna go ahead with our next presentation, Tools to Set Up Great Python Projects by Duarte Pompeu.
Thank you. Can you hear me? Cool. Okay, so today I'm going to talk about tools to setting up great Python projects. So, the motivation for this is, in my experience, there are tools which can improve the quality of a Python project, and they can do this while reducing effort on your part. So you can rely on these tools and for things that you don't need to do manually. So that's my motivation. I picked some tools in specific because these are the ones that I have more experience with, that I find best. But I think most importantly is the methodology and not the specific tools. Sometimes there may be alternatives. Maybe someone can comment at the end with their preferences. My suggestion is that if you are already aware of them, you can I usually set them up from the start, and it makes things simpler. If you are still not using some of them and you want to add, I would say just do it iteratively. Start one by one. You don't need to have all of them fully configured and so on. So in specific, I'm going to talk about package managers, code formatters, linters, and test libraries. Then I'm also going to talk about how to centralize all configurations. This will be useful. And then an extra is about a Python manager. If you have multiple projects, it may be interesting to manage different Python versions. Just some quick words about me. My name is Duarte Pompeu. I'm a software engineer from IDE. I've been working in this area for about 4 years, and I've been working nowadays I'm working for XGeeks, which is a Portuguese consulting company. And thanks to my colleagues, I've already shared the talk internally. I've got some feedback, so you are getting version 2 of the talk, I guess. The better, this was version 0, you are getting version 1. And there's also my LinkedIn. If you want to connect, just search Duarte Pompeu. There shouldn't be too many. Okay, so starting with the first point, this is the one I find the most important, is using a package manager. So the goal of using this is that you can have a reproducible application. Because I remember when I started working with Python during university, I need some third-party library. I just install it, I import it, and then sometime later, I'm trying to rebuild the project in another computer. I don't know how to rebuild it, basically. So I think if you use requirements text, so you are using the tools provided by the Python library, you are using pip and virtual envs, and you are defining them in requirements text, that's a good start. I find that if you are using a full package manager, that's going to be even better. So I'm going to talk a bit about those two. So starting with requirements text, I put here an example. If I want to build a web API, I like test API, I just declare it in my requirements file. I specify a version, and if this is version controlled, someone downloads the project, they can install this as well. In my experience, I found some problems. Either I saw them happen or I did them myself. So first one, forgetting to install in a virtual environment. You run pip install this file, and now it's in your system. Maybe that's not what you wanted to do. So that's bad. You can also forget to write the package down. I've seen it happen. There's a requirements text file. People need a new dependency. They just install it and forget to write in the file. Also, people usually only add direct dependencies. So Fast API, it's going to use other libraries. What version are the other libraries? From this file, we don't know. And another one is that separating between your application dependencies and your development packages, it's going to be a bit of manual work. It's not. This is just a list of dependencies. All of this can be avoided if you are very careful and you are using special parameters in your command line and such. I find that the problem is that you need to be aware of them, be consistent of these workarounds, and I find that usually can lead to problems. So that's why I prefer a package manager. So the one I've been enjoying the most has been Poetry, but I've seen other package managers which do a similar job. So in Poetry, talking specifically about Poetry, what you can do is that in your pipe project.toml, you write the dependencies you want. For example, here I wrote that I want Flask as a main dependency, and in my development dependency, I want PyTest to execute tests. So this second one, I don't want to deploy to production because I don't need it, except for CI/CD and locally. So there I can split this. Another interesting thing is by default, Poetry also specifies the Python version, the minimum Python version. So that's also good. If you have a project from some years ago, it's going to tell which Python version is accepted. That's also interesting. So before I had installed the Flask, and Poetry automatically creates a log file. So in this log file, it's usually a huge file which is going to define all the current versions of all dependencies that you need to build a project. So for example, for Flask, we needed certify. It's at version 23.722. And a year later or whatever, maybe there are newer versions, but if someone installs the project and we added this file to version control, they are going to install this version of certify. And you have quite some guarantees that you can reproduce the project. Okay, so I think that's an important tool. Now, I think this one, not as important, but also can be a bit of an headache if you don't have it. So I think it's straightforward to include it in your project. So that's a code formatter. For me, in general, the goal of this is that you can have a consistent code style across different people. Even if you are, I find that even when I'm working alone on a project, to me, it's faster, run the code formatter. Don't worry about aligning things and such. So in this formatter, we can define some rules and we run it and it will format the code for us. My preference in specific, black plus isort. Once again, if you are already working with other tools, they are also valid. These are pretty popular and I've enjoyed working with them. Starting with black, I like its slogan. It's any color you want as long as it's black. So with this slogan, it also calls itself the uncompromising code formatter. At least that's how it started. It started saying, you don't need to define any rules, just run it, accept our defaults. Over time, they started adding some more rules, but the defaults are pretty okay. So you usually don't need to waste a lot of time. Oh, which rules should I have? How should I format the code? If you just embrace the defaults, it's going to be very straightforward. Then the other one, which black doesn't do, which is sorting imports. This library does it, which is isort. I also like its slogan. I sort your imports, so you don't have to. So sounds good. Regarding isort, what it's going to do, it's going to sort them alphabetically, but it's also going to group them. For example, one group with the standard packages from the standard library at the start, third-party dependencies later, your own modules later. So that's also good to keep things organized. Once again, not a must-have, but if it does it for free, that's something you don't need to worry about, and the code gets more organized. So just a simple example with very messy code. I'm sorry for that. Don't try it at work. I wrote some very long function names, some very long parameters names, the imports. I also put some imports, which I'm not actually using. Yeah, so before applying the code formatter, we get very long lines of code, and that's something we want to improve. So after we run black and I sort, the improvement is not that much because the names are quite bad. So you shouldn't do this, but it was just for demo purposes. It has sorted our imports. It has put some space between them, and our function, it also has, I should be pointing, our function also has been split into multiple lines, so it's not taking as much space. Also here, it has our assignment. It has been split into a multi-line thing with the parentheses. So it did what it could to improve the code. Then the developer should improve the names. But that's one thing it can do. So next, that I also think it can help to have more quality is to apply a code linter. So the goal here is to reduce basic errors. So before ChatGPT and all such, where we are getting reviews for our code, there were these more basic tools where they perform static analysis, and they can see that some things they just are not entirely correct that you may be doing. So they can help you detect defects. My preference, it has been rough with the flake-8 rules. There are many alternatives. In fact, PyLint was one of the first, I believe. There's flake-8 and many others. So about rough, it's a simple slogan, which is an extremely fast Python linter written in Rust. So that's also something popular from a few years ago. Pick tools, rewrite them in Rust. I think an interesting thing is that it can accept rules from many other linters. You can use Rust with rules from PyLint, from flake-8, from many others, and they it still has active development. They are adding more. So I think that's cool that instead of using multiple tools, you use one. And the way to use it is either you run a rough check and it gives you a few warnings about some things that can be improved, or you use --fix. So the things it knows how to improve, and unused import, unused variable, that's simple, just delete it. So if you use --fix, it's going to do that for you. So even less work on your part. And since I thought that it's fast, I picked the graphic from their website. So they mentioned that for the CPython code base, so it's quite a big code base, PyLint, it's going to take over 60 seconds. So that's a lot if you just want to format your code. The other one I've thought, flake-8, that's quite an improvement, almost 6 times, 12 seconds. And then we have rough, which is less than a second on a huge code base. So I've seen that in the code bases that I'm working with, it's pretty much instant. I run it, it tells me the errors, it fixes them. It's very fast. So that's good, because once you are running these tools many times, and if you are running all of them, tests, the formatter, the linter, if they start taking some time, it also starts getting a bit annoying, and it gets in the way. So it's good when they are fast. So okay, so I think this is what I wanted to show. So some code before and after running the Rust with the fix flag is we are doing some imports, we are not using them, we are defining a variable, we are also not using it. So this is very easy to fix with static analysis, and it can just remove the imports and the variable. So if you are in a huge code base, you remove the line of code and maybe the import is not needed, just delete it from the file if it's not needed. So it's basic stuff, but it can help. And it has rules for many linters, so you can opt to go minimalistic, just the basic stuff, or check for a lot of rules, security, best practices, and so on. And it will be more annoying, but can be useful. So talking about something a bit different, which is test libraries. So far, I think the difference is in the other tools, we just use the tool. Now, regarding the test library, according to the one we pick, we also need to write our tests in accordance with it. So there's also a bit of code involved. So as you may know, the goal of testing, or more specific, automated testing, is we want to reduce bugs and we want to reduce manual testing as well. If I'm developing a feature, if I test it manually, I know it works at that point in time. But if I write a test, maybe it takes more time, but it should give me more confidence it's working over time. People run the tests. If it fails, they need to fix something. I think, so Python includes one by default, which is unit test. It's not my preference. My preference is PyTest, but I'll talk a bit about this one to start with. So if we want to define a test in unit test, we are going to need to import it. Then maybe we import our function that we want to test. And we must inherit from a test case. We define our method. And then we use the test case methods, for example, assert equals, and then there is our test. I'm not sure if this is the most practical way to run it, because I usually don't use it, but it was the recommendation in the documents. So to do it like this doesn't seem too much practical to me. On another end, the goal of PyTest is that we can, I think there are two goals. We can simplify when it's a small test, or if we have the need of more advanced testing, it's also going to support it better. So it's simple when it needs to be. It can advance to a more advanced usage. So regarding the code, maybe let me just jump back. So this was the unit test code. And if we move to PyTest, it becomes basically 3 lines of code. We import our function. We define another function called test f, very simple. And we use the native asserts. So I find this very practical for the basic usage. If we want to go into advanced usage, this could be its whole talk, but to give an example that sometimes I do is if I want many tests of the same function, sometimes instead of defining this, basically copy pasting the same test, I like to use parameters. So we had our function which accepted 2 numbers. So, and later we are testing our expected result. We can define multiple parameters. We can give them an ID to also help us organize our code. And then we'll get a report, for example, if this test F with the zeros parameters, it failed. Okay, now we know which one we have to fix. So local, we don't duplicate code. We know which test is failing. I think that's very practical. Just to list some other advanced usage, I'm not going to show code for this, is using fixtures where you need some setup or tear down for your tests, or define a variable and reuse it. You don't need to use global variables, you use a fixture. Conditionals, for example, if you have a basic test and a very complex test which takes some time to run, you can have a conditional, only run the complex test if the simple one passes, for example. I don't use it too often, but I see it can be useful. And then going even more advanced, it supports dynamic generation of tests and quite a lot of stuff. It can be quite advanced. Yeah, so that's why I like PyTest. It can be simple, it can be advanced regarding your necessities. Some other tools that I've used, I'm not going to talk them about a lot, just as a summary if you are interested. One is coverage. So you can run coverage and PyTest, and basically as you run your tests, it's going to measure the coverage. This can be good. And you know, if there is a part of the code you are not testing, maybe you want to. Also, another interesting tool is Hypothesis, which it kind of does testing a bit differently, where with usually on your tests, you define your inputs, your outputs, and you test how it goes. With Hypothesis, you define a more abstract property. For example, let's say, I believe this function f should never crash, should never raise an exception. That's my generic property. Hypothesis is going to feed it random numbers, and it's going to try a lot of variations. And if an exception is raised, it's going to tell me. So I don't know that the output is correct, but I know this property, not raising an exception, or I'm more confident it's working properly. Another tool that I've used, I think this is more specific, may not be relevant for some people, but it has been Locust, where we were asked to do load testing for our application. And we used this briefly, and it's quite nice. So you could do your load testing with PyTest, but this one is more geared towards this. So for example, it can, if you are testing an API, you know, it works for 1 request per second, but does it work for 10? Does it work for 100? So you can write your test that you can tell it, start at 1, finish at 100. And it will report, oh, after when it's at 20 requests per second, it starts giving errors, or the latency starts going up. So that's interesting stuff. If you were to do this with another, just a generic test framework, you would have more trouble capturing this. So I think that's nice for this specific use case. Okay, and now for not a new tool, but how to centralize all these configurations. And sorry, just something popped up. So what's this about? So one difficulty I can see is that when you define all these tools, as I said, some have good defaults, but after some time, maybe you want to add override the defaults. Maybe black shorts your lines to 80 characters and you want 100. But then if one person is running it in the CLI, the other is running in the IDE, and then you put CI/CD into this, how can you enforce the same rule? So I think what you should do is that usually these tools have a default place to look for the rules. You define the rules in the default place, and then you can just run the tools without any parameter. It's going to look at this place. So many tools are now accepting PyProject.toml. For example, here we can define our isort. We can define that it should be compatible. It should run in compatibility mode with Black. We define it here. If we want to specify custom rules for rough, we can also define them here. So this has the advantage of anyone that is running these tools, by default, the tools will look for this file and everyone will be running the same customizations. So I think that's quite nice. It has happened to me before that we are defining this somewhere else, and then we are having problems that CI/CD is enforcing different rules, and now it's hard to make the pull requests pass. But if it's like this, it should be straightforward. Now for an extra, this has been useful to me. I don't think it's useful for all use cases, which is when you need different Python versions. I've worked with microservices before, and sometimes we are upgrading in one service, the other we are still waiting for compatibility and such. So we want to use different Python versions locally. So at least to me, some people just install the latest Python version and run all projects. Sometimes it's compatible. If something gets deprecated, it's not compatible across different Python versions. So I find it just the safe option. Just install different Python versions and manage them. And one useful tool for this is PyEnv. So the slogan is quite boring, lets you easily switch between multiple versions of Python. The usage how I usually do it is I install the Python version I want, and then in my project, I'm using Poetry, and I'm pointing it towards the binary of that Python version. So when I do this, Poetry will run that Python automatically, and different projects, I can point them to different versions. So this is something that it's not mandatory. You can have, if there are 5 people in the project, one person enjoys this workflow, they can use it. The others, they don't need to do it exactly like this. So the other tools, you need some agreement between the team. Everyone must use the same tool. With PyEnv, not so much. So to wrap things up, my goal with this methodology and these tools in specific is that I want to improve the quality of my Python projects, and I want to reduce effort for some tasks. Obviously, they don't do miracles, they are doing more basic tasks, but then I can focus on clean code, good tests, and so on. And we are not discussing code style in our pull requests. So that's nice. Yeah, and just as a summary, so to do this, to me, it's important to use a package manager, code formatter, linter, a test library, centralize the configurations in a specific file, and I find it useful to use a Python manager. So that's it from my side. If there are questions or comments, go ahead. I wrote a small demo. If you want to look it up, it's in this link, it's in this QR code. And there's my LinkedIn again if you like to connect.